Hello everyone and very good afternoon. I hope you all are good and doing well. So today in the class we are going to revise gravitation. In the previous class you all must have done a quick revision of electrostatics. So electrostatics and gravitation are quite same when it comes to concepts and everything. So let's navigate through gravitation. I mean, what are the topics to be studied? I mean, what are the topics from which you will get the question? So, first thing is your universal law of gravitation. Okay, and this is just like Coulomb's law. Acceleration due to gravity. This is just like electric field. Kepler's law of planetary motion. Sorry. We will read Kepler's law of planetary motion. Not read. I mean, we are going to revise it. And gravitational potential energy, gravitational potential, escape velocity, and motion of a satellite and its related things. So these are things to be studied, or these are things, or these are the topics from which question will be coming in your JEE Mains. Okay. Now, if I will just take you quickly through all those things, जैसे we have studied in electrostat Coulomb's force, right? So if there are two charges, separation is R, then force is this. Similarly, in gravitation, if there are two masses and separation between them is R, then force is this. So here you can see there is quite resemblance. Q is getting replaced by mass and K is getting replaced by G. So this replacement is happening. Here also, if one charge is positive, another negative, force is attractive. Here always force is attractive because masses attract each other, right? This is the observation. उसके बाद फील्ड को पढ़ा है इन इलेक्ट्रोस्टैट सो इन इलेक्ट्रोस्टैट फील्ड इज फॉर क्यू चार्ज एट अ डिस्टेंस आर इलेक्ट्रिक फील्ड इज रिटन एज के क्यू बाय आर स्क्वायर right. Similarly for gravity, because of mass there will be gravitational field, and gravitational field indicated by letter G generally is equal to how much? G m by r square. Again kq is getting replaced by m and k is getting replaced by G. Similarly, we have studied potential in electrostat. Because of Q charge at distance R, potential indicated by letter V is equal to KQ by R. Then, if it is positive charge and if it is negative charge, potential is negative, we write minus KQ by R. Done. Similarly, here potential is written always negative because of mass field is attractive, and here G m by R. So again m getting replaced with Q and K getting replaced with G. So this is quite a good resemblance. Similarly, हमने नॉन कंडक्टिंग सॉलिड स्फीयर को पढ़ा है इन इलेक्ट्रोस्टैट. देयर वी नो इलेक्ट्रिक फील्ड value. I mean, for any point P which is outside, electric field is how much? Electric field is equal to KQ divided by R ka square, where Q is, sorry, my pen is getting uncontrolled. Really sorry why this is happening. Okay. Okay. Sorry. So electric field for any outside point is how much? KQ by R square, where Q is what? Q is charge on the solid sphere. Similarly here, if you treat it like Earth, ठीक है. सो अर्थ अगर इसको आप ट्रीट करो फॉर आउटसाइड पॉइंट, ग्रेविटेशनल फील्ड विल बी इक्वल टू हाउ मच? इट विल बी इक्वल टू जी एम बिकॉज ऑफ अर्थ. सो एम मास ऑफ अर्थ डिवाइडेड बाय आर का स्क्वायर. बट जनरली व्हेन वी रीड ग्रेविटेशनल फील्ड बिकॉज ऑफ अर्थ, वी टॉक इट in terms of radius of earth. So this will be radius of earth, and this will be the height of the point P from the surface. So small r can be written as what? Re plus h. So यहाँ पे we will see it like this. Gme by capital R, that is radius of earth, plus height of that point from the surface का square. ऐसा फॉर्मूला हमें अक्सर दिखता है. ठीक है. So this is the formula. Now if there is one approximation, and that approximation is that if h height is far less than that of radius of earth, in that case what will be the g का value? That will be equal to let's say g को मैं g dash लिखती हूँ. ठीक है. So that will be equal to g me by r का square, that is radius of earth, and 1 minus 2h by r. Again, r is radius of earth. ठीक है? So this is the approximation we have taken here, considering h is far less than re, and g me by r square is what? That is equal to electric field on the surface of earth, which is indicated, or which is equivalent to 9.8 into, sorry, 9.8, right? So this is this. चलो मैं इसको एक बार और करती हूँ ऑन द सर्फेस, जैसे यहाँ पे इलेक्ट्रोस्टैट का एग्जांपल मैं लेकर चल रही हूँ, सो दैट इट विल बी मोर इजियर फॉर यू पीपल टू अंडरस्टैंड. सो अगेन, सॉलिड इज नॉन कंडक्टिंग सॉलिड स्फीयर, चार्ज है इसके पास टोटल वॉल्यूम में q. what will be the electric field on the surface? It will be equal to kq by r, where r is the radius of that sphere. Similarly, for earth, on the surface, electric field will be equal to how much? Gm by r square. And this is written as term g, which we know as how much? 9.8 meter per second square, right? So previously I said g dash will be equal to g me by r square, 1 minus 2h by r. So g dash कितना है? g into 1 minus 2h by r. This formula when you will be using, ये formula आप कब use करोगे? When you are calculating a gravitational field at a point P, which is at a height h, such that h is far less than radius of the earth, then you will be using this formula. Okay, this is done. Now what for inside point? So for inside point in electrostat, I have taught you what is the electric field. If charge density, this is charge density, charge per unit volume. Okay, if charge density is rho, then at any inside point, okay, Rohit, yes, what's your doubt? If you have any doubt, let me know. By mistake it happened? Okay. चलो ठीक है, ठीक है, थैंक यू. सो इलेक्ट्रिक फील्ड विल बी व्हाट? रो आर बाय 3 एप्सिलॉन नॉट, वेयर रो इज चार्ज पर यूनिट वॉल्यूम, आर इज पोजीशन वेक्टर ऑफ दैट पॉइंट, एंड एप्सिलॉन नॉट यू नो. नाउ सिमिलरली व्हाट विल बी ग्रेविटेशनल फील्ड इनसाइड एट ए इनसाइड पॉइंट ऑफ अर्थ? सो जी डैश इसको रेप्लिकेट कर दो यहाँ पे. सो रो इज रो हियर रो इज व्हाट? मास पर यूनिट वॉल्यूम, mass of earth divided by volume of earth. R is the position vector. 3 into epsilon naught की जगह क्या आएगा? जैसे G is equivalent to K. K means 1 upon 4 pi epsilon naught. So epsilon naught is equal to how much? 1 upon 4 pi G. So यहाँ पे हमने क्या लिख दिया? 1 upon 4 pi G. But generally in gravitation, formula is not written like this. I mean, we need to further address it. I mean, we need to further simplify it. तो सिंप्लीफिकेशन में तुम्हें कुछ नहीं करना, रो का वैल्यू पुट कर दो. रो इज हाउ मच? m by 4/3 पाई आर क्यू. ठीक है, रो आर इज r by 3 इंटू 1/4 pi g. तो एक काम करती हूँ मैं, 4 पाई, एक्चुअली ना बिकॉज ऑफ कोल्ड आई एम, एक सेकेंड, आई जस्ट नीड टू पिक दिस अप. ओके, सो वी नीड टू रिड्यूस इट. 4 पाई g मैंने लिखा यहाँ. अब इसको तुम ब्रेक करो. सो 4 पाई यहाँ से कैंसिल हो जाएगा, एंड दिस थ्री विल गेट कैंसिल्ड, एंड हियर यू आर गोइंग टू गेट व्हाट? जी एम बाई आर क्यूब इंटू आर, समथिंग लाइक दिस वी आर गेटिंग, राइट? इफ आई एम नॉट रॉन्ग. हाँ, तो ऐसा कुछ आया. इसको अगर सिंप्लीफाई करो, जी एम बाई आर स्क्वेयर. Okay, because of cold, actually, I'm just holding pen very tightly, and that is why I feel like this is happening. Anyway, so G dash G dash will be equal to how much? G m by आर क्यूब था ना, तो इसको मैं आर स्क्वायर लिख रही हूँ इंटू आर बाई आर. ठीक है, जीएम बाय आर स्क्वायर क्या हो जाएगा? ग्रेविटेशनल फील्ड ऑन द सर्फेस ऑफ अर्थ, स्मॉल आर. नाउ देयर इज अ टर्म कॉल्ड डेप्थ. सो क्वेश्चन ऐसे पूछ सकता है कि व्हाट इज द वैल्यू ऑफ ग्रेविटेशनल फील्ड एट ए डेप्थ डी? सो एट ए डेप्थ डी इट इज आस्किंग एट दिस पॉइंट. डन है. सो डी कैन बी I mean, this small r can be written in terms of depth d. How? This hole is the radius of Earth. This is small r. So small r can be written as r minus d. So small r को मैं क्या लिख रही हूँ? R minus d divided by r. So now gravitational field at a depth d we are getting, and that is g into 1 minus d by r. So this is another. ठीक है, तो दो चीजें तुम्हें याद रख तीन चीजें याद रखनी है. ग्रेविटेशनल फील्ड ऑन द सरफेस gm by r square. ग्रेविटेशनल फील्ड एट एनी हाइट h, at any height h is how much? That is gm by r plus h ka whole square. And when you are taking the approximation that h is far far less than r, in that case it is g into 1 minus 2h by r. And when for any depth you are calculating, in that case gravitational field is g into 1 minus d by r. ठीक है, so this is the formula. Now potential energy. So potential energy for two charge systems separated by distance r we write as k q1 q2 by r square. ठीक है, similarly potential energy for two mass systems separated by r can be written like this. Why negative sign? Because here also if one charge is positive another negative, you write potential energy negative. क्योंकि if two charges are opposite, field is attractive, and here masses always attract each other, field is attractive, so potential energy is negative. जैसे इलेक्ट्रोस्टैट में तुम लोगों को पढ़ाया था, if there are four charge system, what is the potential energy of system? Similarly, you can calculate potential energy of system having more than two masses in the similar way. ठीक है, तो please use that analogy. ठीक है, it is very much it very much goes parallel. ठीक है, electrostat and gravitation, so you can use the concept. Now Kepler's law. Kepler's law is what? It defines ki how planet is going around sun. It defines how satellite is going around Earth, or basically it's planetary law. So इन्होंने ये कहा था, he gave three statements. ठीक है, first, second, and then this third statement. So first statement में he defined what will be the trajectory of planets around sun. So he said that trajectory will be what? It will be I don't know why it is happening. Oh my god. एक second. I mean, it's going more fast. Okay, I just need to wait, I guess. Why it happened? It never happened before. Anyway, uh, not responding. Okay, sorry यार. So Kepler's का first law क्या है? He talked about trajectory of the motion. So he said that जिस शेप में और जिस रास्ते पर planet will go around sun, that path will look like ellipse, and sun will be at one of its focus. ठीक है, and this is your plan, so it will be elliptical. Second था उनका law of area. So इन्होंने ये कहा कि area swept by planet. So if planet is sweeping area, suppose this area is some value delta a in time delta t, and in the same time delta t it is going from here to here, and this is delta A dash, then he said that area swept in equal interval of time will be same. So here, since time interval is same, delta A dash will be equal to delta A. So he simply said that aerial velocity is constant. Aerial velocity is what? It is constant. और इसका value कितना था? इसका value था L by 2m, where L is the angular momentum of planet and m is the mass of planet. ठीक है, इसका कंसिक्वेंस देखो, अब मैं उतने एक्सप्लेनेशन में नहीं जा सकती, बट इसका कॉन्सिक्वेंस ये भी था कि व्हेन प्लैनेट विल बी फार फ्रॉम द सन, देन इट्स वेलोसिटी विल बी स्मॉलर. ठीक है, हमेशा याद रखना, यहाँ से क्वेश्चंस आता है. सो व्हेन प्लैनेट विल बी फार फ्रॉम द सन, velocity will be less, and when it will be close, velocity will be what? Higher, just to make aerial velocity constant. है ना, एरियल वेलोसिटी कांस्टेंट है, इसलिए ये वेलोसिटी का प्रोफाइल ऐसा हो रहा है. डन है. सो जब यहाँ पे अगर तुमसे पूछता है प्लैनेट का वेलोसिटी यहाँ v1 है, और यहाँ से यहाँ जाने में अगर v2 है, तो यू विल क्लियरली से दैट v2 इज ग्रेटर देन v1. डन है, याद रखना इस चीज को. चलो, सो तीसरा लॉ क्या था? तीसरा लॉ वाज लॉ ऑफ पीरियड. सो इट सेड दैट टाइम पीरियड, टाइम इन विच प्लैनेट विल गो अराउंड सन, I mean, time in which it will complete one rotation, square of it will be directly proportional to half of the major axis. So major axis is what? This whole length, 2a. So half of the major axis means a ka whole cube. T square is directly proportional to a ka whole cube. So this is 3 Kepler's law. ठीक है, चलो। नाउ प्लैनेटरी मोशन, यहाँ से बहुत क्वेश्चन आए हैं प्रीवियस ईयर क्वेश्चन अगर तुम देखो तो ग्रेविटेशनल फील्ड और प्लैनेटरी मोशन से सबसे ज्यादा क्वेश्चन था। सो ऑर्बिटल वेलोसिटी, जैसे हम लोग फॉर द सेक ऑफ कैलकुलेशन वी ट्रीट ट्रेजेक्ट्री नॉट एज एलिप्स बट एज सर्कल। ठीक है, सो चलो यहाँ पे देखते हैं कि सपोज ये सन है और यहाँ पे प्लैनेट, और ये अर्थ है और ये सैटेलाइट, वॉट एवर बी द केस। अगर ये प्लैनेट चारों तरफ जा रहा है सन के चारों तरफ, सो इट इज गोइंग इन अ सर्कल। इट इज गोइंग बिकॉज सम सेंट्रीपिटल फोर्स इज एक्टिंग, एंड what will provide here centripetal force? Gravitational force. So mass of sun ms ले लो, mass of planet mp ले लो. So gravitational force acting here is how much? I mean, why it is happening? G ms mp divided by what you will write here? This is your r ka square. So this is the gravitational force, and this is responsible for what? This is responsible for your centripetal acceleration. Or done it. So this can be written as mass of planet into velocity of planet का square divided by radius, mv square by r. So यहाँ से तुम velocity निकाल सकते हो. Velocity कितना आएगा? mp कट जाएगा, g ms by r. So this is the formula of orbital velocity. You should know the derivation, क्योंकि directly formula will not help you always. ठीक है, हमेशा वो help नहीं करेगा. So you should know from where it is coming. डन है। उसके बाद है टाइम पीरियड। देखो टाइम पीरियड कैसे निकालोगे? सो टाइम पीरियड इज सिंपल, द टाइम इन विच इट विल कंप्लीट द होल रोटेशन, राइट? one complete rotation. So if you have to calculate time period is what? 2 pi by omega. This is the general formula. And just now we have written one thing. V is equal to what? V equal to what? Omega r, we know in circular motion. We have already calculated, that is how much? Gm by r. So this is equal to omega r. And from here you can calculate omega, right? So if you're going to calculate omega, this will be equal to Gm by r cube root under something like that you will get, right? So t equal to तुम क्या लिखोगे? T equal to 2 pi by omega, and omega is how much? Root under Gm by r cube. ठीक है, if you're going to square on the both side, you will get t square is directly proportional to r cube, just like law of period, right? So we got from here. But the thing is you should know derivation कि टाइम पीरियड कहाँ से आया। सबसे पहले हमने ओमेगा निकाला। ओमेगा कैसे निकाला? v से। v कैसे निकाला? सेंट्रीपिटल सॉरी ग्रेविटेशनल फोर्स को mv स्क्वायर बाय r से इक्वेट किया था। सो इट्स इंपॉर्टेंट, दैट इज व्हाई आई एम डिस्कसिंग नाउ। एनर्जी ऑफ प्लैनेट, जब प्लैनेट सन के अराउंड जा रहा है तो उसकी एनर्जी क्या होगी? एक तो पोटेंशियल एनर्जी होगी, बिकॉज टू मासेस आर एट सर्टेन सेपरेशन. सो पोटेंशियल एनर्जी यू विल राइट एज व्हाट? माइनस जी एम एस एम पी डिवाइडेड बाई आर. ठीक है, एंड इट विल हैव काइनेटिक एनर्जी बिकॉज इट इज हैविंग वेलोसिटी v. सो काइनेटिक एनर्जी आप लिख लेना, हाफ मास ऑफ प्लैनेट इंटू वी का स्क्वायर. वी कितना था? जी एम एस बाई आर का रूट अंडर, स्क्वायर किया तो ऐसा हो गया, यानी कि एम पी एम एस बाई 2r. ठीक है, सो what is the total energy we are going to get? Total energy will be potential energy plus kinetic energy. If you are going to add it, you will get minus gmsmp by 2r. So if you look at here carefully, total energy का जो magnitude है वो kinetic energy के magnitude के बराबर है, and this is potential energy के magnitude का half. ठीक है, so this right? So you should remember all these things from where it is coming. उसी तरह से अगर तुमसे पूछता है कि there is earth, satellite is going around it in a orbit. Suppose question is like this, there is a satellite and it is going around earth in an orbit r. So tell me what will be the energy of satellite? So if it is going round and round, then its energy will be total energy, I mean potential plus kinetic. So minus g mass of earth, mass of satellite by 2r. If this satellite is just kept on the surface of earth, suppose, or at certain distance in rest, then it will have only potential energy, and that is minus g me ms by how much? R. ठीक है. So you will read the question carefully and then you will try to answer this. So here is your first question. Let's start from here. ठीक है, take your time. I will give you 1.5 minute. Take your time and let me know. ठीक है, चलो करो, आंसर्स करो. Yes. Okay, I raised my hand. This is amazing. Yes, my dear everyone over here. Rohit, Harish, Janvi, Yanam. How's the thing? सभी लोग करो. दिस इज सिंपल फॉर्मूला एंड ऑल क्वेश्चंस आई हैव टेकन फ्रॉम प्रीवियस ईयर, जस्ट फ्रॉम 2024. सो दिस क्वेश्चन इज फ्रॉम जेई मेंस 2024. एवरीथिंग इज फ्रॉम 2024 जेई मेंस, ऑल द क्वेश्चंस. ठीक है. व्हाट इज द आंसर यू आर गेटिंग? एनीवन गेटिंग द आंसर? यस. Okay, I've launched the poll क्योंकि you people hesitate in talking. Yes, Rohit, very good, very good. Keep it up. So, one person has already, one student has already given me the answer. So I will go fast now. What is the question? Okay, JNV Yanam, very good, very good. Harish, you also must have got it. So now let's look at it. Assuming Earth to be a sphere of uniform mass density, weight of body at a depth r by 2 from the surface of Earth. If its weights on the surface of Earth is 200 Newton. So weight is equal to what? mg. On surface of Earth, m into what likhoge? M into g. And at depth d, what will be the weight? So weight at depth d will be m into g dash. And g dash will be equal to how much? G into 1 minus d by r, right? So in the question, what is given? Depth is how much? Equal to half the radius of Earth. So here you will write r by 2 by r, that is this. So 1 minus 1 by 2, that is mg by 2. So correct answer will be how much? Half of the previous one. So that is 100 Newton. Very good. Next. Yes. Again, formula based questions. This is also from 2024. Everyone do it. ठीक है. I'm going to end this poll and I'm going to relaunch it. ठीक है, so that you can answer. चलो. देखो, everyone has to keep courage and keep reading. ठीक है, तुम लोग का मार्क्स अच्छे आ सकते हैं और आएंगे. So there is no worry in that. Yes, very good. Janvi, Yanam, I got one answer. Very good. Others? Temperature here is 0 degree. Can you imagine? And my hand is not working actually. It's too cold. Yes, more answers, please. Come on, everyone. Show your energy. You are kept in good temperature to work, right? So write fast. Question is from orbital velocity, right? Two satellites A and B go around a planet P in circular orbit having radius 4r and r. So for one, radius is 4r, and for another, radius is r. And what you have to, if the speed of satellite A is 3v, then what will be the velocity of satellite 1? Harish. Yes, very good. सो ऑर्बिटल वेलोसिटी अभी अभी मैंने बताया कितना होता है, जी एम बाई आर. सो फॉर फर्स्ट ऑर्बिटल वेलोसिटी विल बी हाउ मच? जी एम बाई 4r root under, and this is equal to 3v. Now what will be the v dash? This will be equal to gm by r. Done. So gm by r from equation 1 is equal to how much? If you look at gm by r, 4 को बाहर लेकर आओ, हाफ हो जाएगा, एंड दैट हाफ will go this side 6b. So gm by r is equal to 6b. So correct answer is what? B. Very good, everyone. Thank you. चलो, let's do this question. Take time, do it. ठीक है? You need to think a bit in this question, not to think in terms of concept, but in terms of how to solve it easily. ठीक है? So do it. Okay, I got somebody answering. JNB, yes, correct. Yeah, it's good. Come on, everyone. I got one answer. I'm counting more. ठीक है, take your time, do it. No worries. More 30 seconds I will wait. ठीक है? After that, we will do it together. So this is from satellite portion और energy conservation यहाँ पे use में आएगा. So take more some seconds and think over it. चलो ठीक है. Now let's do it together. I will make you understand it very clearly. ठीक है? Let's try. A satellite of mass 10 to the power 3 kg is revolving in a circular orbit of radius 2r. So it is revolving in a circular orbit of radius 2r. If 10 to the power 4 r by, now this satellite is moving like this. Okay? So if it is rotating, what will be its total energy initially? How much is the energy? So I told you total energy is minus gmm by 2 into orbit radius. So minus gmm divided by 2 into orbit ka radius, that is here 2r. Now what we are doing to it, we are adding this much of energy to the satellite. So if we are giving it this much of, I mean, if we are giving it some more energy, it won't remain in the orbit 2r, because if it is in the orbit 2r, it has this much energy. And if its energy is increasing, we are giving it more, then it will go in the higher orbit. ठीक है? Because as जैसे total energy का formula is what? Minus gmm by 2r. As the r will increase with negative sign, total energy will increase, right? So if you're giving it some more energy, it means you are letting it go into higher orbit. So let's say now it is in the orbit of radius small r. So with total energy initial, if you are adding 10 to the power 4 r by 6, it will go into some other orbit जिसकी energy इसके बराबर होगी. So if I am telling कि another orbit is of radius r, then total energy is minus gmm by 2r. Now you just need to solve it to get the answer. But be very wise, क्योंकि हमारे क्वेश्चन में दिया हुआ है सैटेलाइट का मास इज 10 to the power 3 kg. So 10 to the power 3 is a small m, and here 10 to the power 4 का term है. So 10 to the power 4 can be written as small m into small g, that is acceleration due to gravity, and that is equal to gm by r square. So 10 to the power 4 को I am going to replace it by this for easy calculation, because total energy is given in terms of gmm by 4r. So plus 10 to the power 4 को मैं क्या लिखूंगी? This. और 10 to the power 4 r को क्या लिखूंगी? This into r. So this is gmm by how much? 6. Okay. No, I will do one thing. Gm by r square. gm by r square is your what? That is your 10. So here, okay, gm by r square था ना ये तो, आई मीन m इंटू 10, 10 to the power 4 r था ना, उसको मैंने ऐसे लिखा 10 to the power 3 इंटू 10 इंटू r। इसको मैंने स्मॉल m लिया, इसको मैंने g लिया, तो g को हम क्या लिखेंगे? gm बाई आर क्यूब, नहीं r स्क्वायर होता है ना। सो दिस इज दिस, नाउ दिस इज 6r एंड दिस इज इक्वल टू माइनस जी एम एम बाई 2r। नाउ यू नीड टू सॉल्व इट, राइट? सो एक काम करो, डिनोमिनेटर को मैं सेम करूंगी। सो 6 से मल्टीप्लाई डिवाइड किया, यहाँ पे 4 से multiply and divide किया। So what we are going to get, minus 2 GMM by 24R, and this is equal to minus GMM by 2R, right? So what is the answer we are going to get? We are going to get 6R as the answer. Small r is 6R. So correct answer will be what? It will be 6R. I hope it is clear. Is it clear to everyone? किसी को डाउट है? Anyone? नो मैम, थैंक यू हरीश। चलो आगे फास्ट मूव करते हैं फिर। डू दिस क्वेश्चन, ठीक है? दिस इज इजी वन, यू डोंट नीड टू थिंक दैट मच। अप्लाई द कॉन्सेप्ट, टेक योर टाइम, डू इट। ओके, आई गॉट वन करेक्ट आंसर। ओके, यार, जेनवी, यनम, ठीक है। अदर्स प्लीज। I hope each one of you are doing it. Should I make you understand? Question is like, to project a body of mass m from Earth's surface to infinity, the required kinetic energy is what? So this is basically a question from your what? Uh, what is that called? आई मीन escape velocity. So देखो, मैंने escape velocity डिस्कस नहीं किया। आई थॉट टू डिस्कस इट थ्रू क्वेश्चन। सो क्वेश्चन ये कह रहा है कि सपोज समथिंग इज ऑन द सर्फेस ऑफ बॉडी, ठीक है? समथिंग इज ऑन द सर्फेस ऑफ बॉडी एंड यू हैव टू escape it to infinity, ठीक है? You have to take it to infinity. So what will happen if the body is on the surface? It's not revolving around the earth, it is just kept on the earth. So energy of the body will be negative, only potential energy, है ना? Minus gmm by r, radius of earth, because it is kept on the surface of earth. When you will take it to infinity such that its velocity is still zero, then here its energy will be how much? When object is at infinity, potential energy will be zero, क्योंकि उस केस में सेपरेशन दोनों अर्थ और बॉडी का सेपरेशन विल बिकम infinity, and in that case potential energy is what? Zero. So basically, if you have to throw a body from surface of earth to infinity, you need to give it some energy such that its total energy will become zero. Then only it will reach to infinity, because at infinity energy is zero. So if you have to take it from surface to infinity, you have to make its energy zero. Done it? So we are going to give it some positive energy, kinetic energy, such that when it will get added to its potential energy, it will become zero. Okay? So how much kinetic energy we will give? Equal to the equal to negative of potential energy, that is equal to gmm by r. So if you think, see here carefully, अगर मैं एक और r से multiply कर दूं और यहाँ पे भी लिख दूं, then gm by r square will become small g, and then this will m, and then this will be r. So mgr, how much kinetic energy we are going to give it? Mgr. From here also you can derive escape velocity. So kinetic energy हम कितना दे रहे थे? Potential energy के negative के बराबर. So kinetic energy formula half mv square, and this is equal to how much? Gmm by r. So mm will get cancelled, and escape velocity is how much? 2 gm by r. So double the orbital velocity if body is orbiting in radius capital R. डन है. एंड इसको अगर सिंप्लीफाई करोगे, सॉरी फिर से, दिस इज टू बैड. ठीक है. सो हियर 2 gm बाई, अगर आर स्क्वायर में कर दूं तो आर से मल्टीप्लाई करूंगी, सो दिस विल बिकम 2gr, एंड दिस इज escape velocity. डन है. बट ऑलवेज रिमेंबर दिस इज escape velocity when object is kept on the surface of earth in rest, and then if you have to escape it, then we give it this much velocity. Done. Sometimes in question it is asked that there is a body which is going round and round around the earth, and then how much velocity you will give it to escape. So then you have to use the concept. Concept is what? Concept is write its initial energy. So how much extra energy you need to give? That much, which will make its total energy equal to 0. That's the concept. So that is the concept you have to use. You can use formula if it is given that object is kept on the surface of earth in rest, and then if it is asked what velocity you will give it to escape, that will be root under 2gr, which is called escape velocity. Okay. So this is the formula then used. And here kinetic energy was asked. तो अगर escape velocity तुम्हें डायरेक्टली फॉर्मूला पता होता तो तुम डायरेक्टली यहाँ पे लिखते हाफ एम वी स्क्वायर, क्योंकि इस क्वेश्चन में ऑब्जेक्ट इज केप्ट ऑन द सर्फेस ऑफ अर्थ इन रेस्ट. वी कैन यूज द फॉर्मूला. सो हाफ एम वी का स्क्वायर क्या लिखोगे? 2gr. सो दिस इज mgr. सो करेक्ट आंसर इज व्हाट? दिस इज द कॉन्सेप्ट. ठीक है. चलो, नाउ डू दिस क्वेश्चन. हियर यू जस्ट हैव टू डू विद द डायमेंशन. सो डू इट एवरीवन. Okay, I got 2 answers previously. That's great. Everyone is doing brilliant. You people are here. That's great. That's good. है ना? See, so many of them are not here. That also counts. Okay. I hope you are solving it. It's very important that you solve it and then let me know the answer. Okay? If you're solving it, then letting me know, it's fine. I'm just saying. Okay, I got 2 answers. That's great. Okay, so what will be the answer you will be getting? Root under U and G. U क्या है तुम्हारा? U is mass per unit volume, right? Or energy per unit volume. What is this? Energy density. That is energy per unit volume. So इसका dimension क्या होगा? Energy is ml square T minus 2. Okay. Uh, I don't know. It's getting freezed, I guess. I don't know. ठीक है. It was not happening. चलो ठीक है. So I'm going to write the dimension for E by V. एक second, just give me some time. I mean, why? So I'm just praying with the God it doesn't happen this time. I mean, why? So U is energy per unit volume, right? Okay. For now, I will try verbally. Okay. So U is what? Energy per unit volume. That is equal to how much? ml square t minus 2 by L cube. G का dimension, how you will calculate? You already know force का value, है ना? Force क्या होता है? Force किसके बराबर होता है? G m by r ka square. So this is force. And from here we can calculate dimension of G. Force is how much? ml square t minus 2. So G m square by L ka square. So G ka dimension will be equal to how much? It will be equal to m minus 1 and ओके दिस इज फोर्स ना एम एल का पावर वन होगा ठीक है सो एम माइनस वन एल क्यू टी का पावर माइनस टू जस्ट पुट द वैल्यू ओवर हियर ठीक है सो यू का वैल्यू कितना था यू इज योर एम एल स्क्वेयर टी माइनस टू बाई एल का क्यूब सो दिस इज इक्वल टू एम एल माइनस वन टी माइनस टू एंड दिस इज इंटू एम माइनस वन एल क्यूब t minus 2. So how much value we are going to get? M will get cancelled and here we will get L का value square में मिलेगा हमें and T का value in minus 4. LT minus 2 is your what? Acceleration है ना? So force per unit mass is what? Acceleration. So this is basically this is LT minus 2 and this is nothing but acceleration. So that is force per unit mass. Force by mass क्या होता है? This is acceleration, right? Now let's do the next question. हाँ, do it now. Take your time, do it. Okay, Janvi Yanam. Yeah, it feels correct. देखो height of satellite is getting asked from the Earth's surface and the answer is in term of time period, radius and a small g. So you should know what formula to use. Time period का formula you can use. ठीक है जैसे time period हम कैसे निकालते हैं 2 pi r by velocity. So if satellite is going around Earth, suppose at a height h, then a small r can be written as r plus h. That is why while explaining I told you it's significant how differently you can write a small r. That is radius of Earth plus height. So r plus h. And v is what? V is here orbital velocity of this satellite in radius small r, right? So what will be the orbital velocity? That will be equal to your gm by root under gm by small r. Use that thing and now try calculate. ठीक है ठीक है I hope now you will get the answer. So you just write here v equal to root under gm divided by small r. ठीक है what is this here? Never happened. I don't know. Okay, tell me the answer. Anyone else got it? Yes. So you just put here. I mean, problem. Okay. Just give me some time. This pain has got some problem. Can you hear me, everyone? Yes. Okay, now it is working. Oh my God, this is real trouble, you know. I don't know why it started. 2 pi r by v, ठीक है? So 2 pi r का वैल्यू क्या रखोगे? R plus h. या फिर एक काम करते हैं, पहले r का वैल्यू r ही रहने देते हैं, ठीक है? लास्ट में we will put h. So here you will write 2 pi r. v को क्या लिखोगे? Root under gm into root under r. So this is 2 pi. R का value how much? 3 by 2 divided by root under gm. Now we have to calculate what? Height. So एक काम करो, t का square लिखो. t का square will be equal to how much? 4 pi square by gm. स्मॉल r की जगह क्या लिख सकते हैं? R plus h 3 by 2. Now what r plus h can be written as? So r plus h by power 3 by 2 can be written as gm by 4 pi square, है ना? gm by 4 pi square into t square. This can be written like this, right? And r plus h simply 3 by 2 power इधर लेकर जाओ. So this will become 2 by 3. Done है? Uh, I mean, this was 3 by 2 power. Am I? No, I have done some calculation mistake. How we will take the power here? Let me delete it. So r plus h ka power is 3 by 2, right? And r plus h 3 by 2 is this. T ka square. Okay. Now we have to write r ka square, right? So what we can do here? I mean, you just need to check with the calculation. Sorry, my mind was stuck with that problem. But can you see here t equal to 2 pi r by v लिखा हमने. This is t का square किया. We need to square this side also. If we are going to square it, then this will become r plus h का whole cube, right? Because we have done squaring on the both side. t जैसे t का square किया तो इस पूरे का भी square हो जाएगा, right? So पूरे का square करोगे तो r plus h का power 3 by 2 था. When you are squaring, that will become 3. है ना? 2 will go away. So r plus h किसके बराबर होगा? gm जी एम बाई 4 पाई स्क्वेयर टी स्क्वेयर का पावर कितना जाएगा? 1/3. नाउ जी एम का टर्म इज नॉट गिवन इन द ऑप्शन, सो डू वन थिंग. जी एम बाई आर स्क्वेयर टर्म लाना पड़ेगा हमें. सो आर स्क्वेयर आप यहाँ लिख दो, आर स्क्वेयर यहाँ लिख दो. सो जी एम बाई आर स्क्वेयर विल बिकम स्मॉल जी. सो दिस इज स्मॉल जी, है ना? आर स्क्वेयर टी स्क्वेयर डिवाइडेड बाई 4 पाई स्क्वेयर, एंड दिस इज इक्वल टू 1/3. ठीक है? सो टी स्क्वायर आर स्क्वायर जी बाई 4 पाई स्क्वायर 1/3. सो एच वैल्यू विल बी दिस माइनस आर. सो करेक्ट आंसर विल बी 2. यू नीड टू बी मैथमेटिकली करेक्ट. ठीक है? यस. व्हाट हैपेंड? द स्क्रीन वेंट अवे. ओके, आई कैन नॉट सी द स्क्रीन. एक सेकेंड, एक सेकेंड, आई एम रीशेयरिंग इट. देयर इज प्रॉब्लम विद दिस क्रशर, आई गेस इट्स टू फास्ट. ओके, चलो ठीक है. नेक्स्ट क्वेश्चन वी विल डू नाउ. सो दिस इज योर नेक्स्ट क्वेश्चन. डू इट फास्ट. ठीक है? यहाँ पे यू विल रिक्वायर कॉन्सेप्ट. सो डू इट फास्ट. जस्ट द कॉन्सेप्ट यू नीड टू राइट, नथिंग एल्स. Here it is given that force of attraction between planet and star is proportional to r का power -3/2, and then you have to calculate time period. ठीक है, so you need to go with the derivation, क्योंकि यहाँ पे फोर्स को जी एम एम बाय आर स्क्वायर नहीं लिख सकते, बिकॉज हियर इट्स गिवन फोर्स ऑफ अट्रैक्शन इज प्रोपोर्शनल टू आर का पावर -3/2. डन है. तो यू हैव टू कैलकुलेट टाइम पीरियड. टाइम पीरियड कैसे निकालोगे? 2πr/v. वेलोसिटी कैसे निकाला था हमने? ग्रेविटेशनल फोर्स एक्टिंग इक्वल टू mv² by r. सो हियर ग्रेविटेशनल फोर्स इज प्रोपोर्शनल टू r का पावर -3/2. सो ऐसे करना, mv²/r को लिखना इक्वल टू सम कांस्टेंट k इंटू r का पावर -3/2. सो फ्रॉम हियर ट्राई टू सी v इज प्रोपोर्शनल टू व्हाट पावर ऑफ r. ठीक है, सो mv²/r एंड दिस इज r. डन. सो v स्क्वायर विल बी डायरेक्टली प्रोपोर्शनल टू व्हाट? r का पावर -3/2 प्लस 1, है ना, दैट इज -1/2. v स्क्वायर इज डायरेक्टली प्रोपोर्शनल टू r का पावर -1/2. and if you will take that power this side, then this will become r का पावर -1/4, right? and then you will calculate time period. time period कैसे निकालोगे? 2πr/v. डन है. सो फ्रॉम हियर यू विल राइट 2πr, और वेलोसिटी क्या है? सम कांस्टेंट k इंटू आर का पावर -1 बाई दिस इज हाउ मच? 1/4, राइट? इफ आई एम नॉट रॉन्ग विद द कैलकुलेशन, यू नीड टू चेक विद द कैलकुलेशन. ठीक है, सो यहाँ से आर का पावर अगर ऊपर ले जाओगे तो कितना हो जाएगा? 2π/k. आर का पावर 1 + 1/4, दैट इज 5/4, right? So this is your t. So t square is directly proportional to what? r का भी इधर स्क्वायर करोगे, so that is r का पावर 5/2. तो देखो यहाँ पे हम ब्लाइंडली वी कैनॉट से कि टी स्क्वायर इज डायरेक्टली प्रोपोर्शनल टू आर क्यूब. ये ऑप्शन कब करेक्ट होगा? व्हेन ग्रेविटेशनल फोर्स इज रिटन है जी एम एम बाई आर स्क्वायर, यानी कि व्हेन फोर्स इज इनवर्सली प्रोपोर्शनल टू आर का स्क्वायर. बट इन द क्वेश्चन इट इज गिवन फोर्स इज डायरेक्टली प्रोपोर्शनल टू आर का पावर -3/2. सो यू नीड टू डू द होल डेरिवेशन एंड देन राइट द थिंग्स प्रॉपर्ली. ठीक है, सो ऑलवेज हैव दिस इन योर माइंड. ठीक है, do this last question and then we will leave. ठीक है, 1 minute is left, but this is just like कि तुम 4 corners पे चार्ज को रखते हो तो कैसे फोर्स निकालते हो, है ना? ग्रेविटेशनल फोर्स. सिमिलरली यू कैन कैलकुलेट यहाँ पे, अगर सॉरी इलेक्ट्रोस्टैटिक फोर्स, इफ masses are kept then how you will calculate? So vectorially you will do it, right? So that vector method you have to apply here. ठीक है, that will be always attractive, so you can try this question. ग्रेविटेशनल फोर्स एक्सर्टेड ऑन वन ऑफ द मास तुम्हें निकालना है. तो यहाँ पे एक मास है, एक यहाँ है, एक यहाँ, एक यहाँ. ठीक है, क्लोजली लिख डालो, मैंने काफी दूर दूर लिख दिए हैं. सो यू हैव टू कैलकुलेट फोर्स एक्टिंग ऑन एनी वन मास बिकॉज ऑफ अदर मासेस. ठीक है, एंड रिमेंबर ग्रेविटेशनल फोर्स इज ऑलवेज अट्रैक्टिव. So, keeping time in mind, I will just solve it with you. So, यहाँ पे suppose मैं इस पे force निकालती हूँ because of all three masses. So, this small mass is, पहला small mass is, will attract this m mass towards itself. This small mass m will also attract it towards itself, and this m mass will also attract it towards itself. So, there are three forces acting: F1, F2, F3. If you say a side of a square is a, then f1 is equal to how much? G m square by a square. f2 का मैग्नीट्यूड भी कितना होगा? gm square by a square. Magnitude same है, direction is different. f3 will be equal to how much? gm square by, ये distance कितना है? √2a होगा. So उसका square करोगे तो कितना हो जाएगा? 2a square. So if you look at the magnitude, then f1 is equal to f2 and this is equal to 2f3, right? And three forces we have to add. Now, if you are going to add F1 and F2, F1 and F2 are at 90 degrees and they are equal in magnitude. So their resultant will go bisecting this thing, yani ki along this direction. F1 plus F2 will be along the direction of what? F3. And what will be the magnitude of F1 plus F2? When we add two vectors at 90 degree, how much value will get? F1 square plus F2 square plus 2F1 F2 cos 90. Cos 90 is 0. So basically this is √2F. If magnitude is same. So magnitude is same here. So √2F it is. F मैं किसको बुला रही हूँ? F1 या F2 को F ले. ठीक है? So this is this, right? Now total force will be equal to what? Total force is equal to total. It is equal to F1 plus F2 plus F3. So F1 plus F2 तुम्हारा कितना आया? √2F. और F3 तुम्हारा कितना है? F3 is how much? It is equal to F by 2. So what will be the answer? Answer will be 2√2 plus 1 by 2F. F कितना है? gm square by a square. नाउ देखो यहाँ पे 2a स्क्वायर किसके बराबर है? क्वेश्चन में 32l स्क्वायर. सो फ्रॉम हियर यू कैन सी l a इज इक्वल टू 4l. डन है. सो आंसर विल बी योर 4l. I hope it is clear. In the next class, we will meet with next topic. ठीक है? Seeing the time, I need to end the class because 11th class is to get started on this same channel itself. So everyone take care of yourself. Keep your mind healthy and positive. Keep solving more number of questions. Don't hesitate in reaching out to us. If you need any extra help, let us know through your coordinator. We will be there to help. Okay? So please take care of yourself. Stay safe, stay healthy, keep enjoying. Bye bye, take care. And thank you for staying till the last. Thank you so much. Bye bye, everyone.